Okay, so let's get started. So if you can do like a 1-minute brief intro about like who you are, what you're looking for, that type of stuff, and then we can get started.
So yeah, let me start with the introduction. I'm Aman. I have nearly like 4.5 year of experience in some startup and MNCs as well. So I'm targeting uh, L4 and L5 level roles across like MNCs.
Okay, and so L4, I guess it's different in different companies. So is that like mid and senior, I guess?
Yeah, senior level roles.
Senior level roles. Okay, cool. Yeah, sounds good. Okay, so I'm going to give you the first question, and you're going to have an hour. So let me just write down how long we're going to have here. So it's 12:04, so we'll go until 1:04. And you basically need working solutions to both, and you need to be, and you can run your code. Okay.
Oh,
So the first question is you're going to be given, and by the way, if you've done these, let me know and I can swap. Just so it's not like too
mhm,
easy for you. It's more realistic. So you're going to be given a list of accounts,
mhm,
and I can paste an example. So here's an example. So you're going to be given a list of accounts, and it's going to be something like this, where every single row will
mhm,
have a bunch of emails.
mhm.
And so the accounts are always going to be like a name and then a list of emails.
Okay.
And what I want you to do is if two people have the same email,
Mhm.
then we know for sure they are the same person.
Right.
So what I want you to do is basically merge the people with the same emails and return to me an output with those things merged. So in this case, that would look like this. And let me explain it real quick. So basically, in this case, we have 3 Johns and we have a Mary. So Mary's by herself, and 2 of the Johns got merged because, let's see. Yeah, so this first and second John have the exact same email. So basically,
Mhm.
this johnsmith@gmail.com, john00@gmail.com, and johnnewyork@gmail.com should be merged because they're the same person. And the last person has an email that's not anywhere else, so it's totally possible for 2 people to be named John and have different emails. But if they have exactly the same email, then you know they're the same person. Does that make sense?
Yeah, that makes sense.
Okay.
One quick question before I think of any solution. What happens if the given input is not valid? Let's suppose the on line number 4, right?
Mm-hmm.
The name is John and the following email is same. On the line number 5, the name is John 2, or let's say the name is Mary, and these are the email. Based on the info that you shared, right? These two be merged, should be merged, but they have like different names.
So you can assume that everything that should get merged it will always be valid. So you'll never have a case where like there's 2 email, like Mary and John have the same email and they're different names. So you can assume the input's always valid in a way where if they have the same email, they're the same person for sure, guaranteed.
Okay.
And you can also assume like you're always going to get like a, I mean, I guess you can get like an empty array, but you're never going to get like John and then blank or something. So you'll always get at least like for every line, it'll be at least one person and at least one email.
So based on the given input, I think this should go in the direction of the graphs or trees. Each of this email can be connected, let's say, no, nodes in a graph.
Okay. So how would that work?
Yeah, let's suppose uh, since each of this, let's say we assign each of these accounts as a node in a graph, right?
Mm-hmm.
And how the connections would work is like each of these emails are interconnected for each of this. So the node that I'm storing is, let's say, first email.
Mm-hmm.
Then there is a second email. These two are interconnected because like they share. We already know that these belong to the same person. And
Okay.
the second as well, like we would connect this like we would basically create nodes for all of this. If we see like a node is already existing, we would try to connect with the others. Later we can do BFS, or let's say DFS, to figure out like what are the emails that belong to a same person named John.
Okay. So when you say you will connect the nodes, what would a connection look like?
Connections would be between the emails only. So John Smith would mail.com would be connected to the
Right.
second one.
I mean, like, would it be like an undirected edge, a directed edge? Like, how would you actually store that?
It would be under directed edge. So basically, we can move across one mail to another mail.
Okay. So can you walk through this example with kind of what you're gonna do and how you're gonna like connect things, and then how you'd get a result, just so I can understand clearly that what you're doing makes sense?
Yep.
Okay.
So let's start with the John first. We are given this first mail of the John, and there is a second mail of John, right?
Mm-hmm.
There can be two ways to do it. One can be, let's say, instead of going with the, let's say, string using the strings to string map, or basically connecting a string to string, we can hash this out. But that is like optimization part. I will commit to later.
Mm-hmm.
We loop over all the emails and interconnect those, like all of the emails that exist for first John.
Okay. Makes sense so far.
Yep. We again got the same John. We try to create a node, and we keep a track of, like, have we created a node for this email or not. That can be used using, let's say, set or something like that. Or if we are using the particular implementation in, let's say, Python, we can look up in the dictionary key if the key exists or not.
Okay, so basically like an adjacency list with emails, right?
Yep.
Okay, it makes sense.
So if it exists, if it already exists, we pick up the node and try to connect the other nodes. If it doesn't exist, then we create a new node, and yeah, the same process we follow. So
Yep.
JSON is made at gmail.com already exists. So we move on to the second one. We see this, how many nodes it can be connected to. So we can connect it with this one as well. So we create a new node. And try to connect across all the nodes. So it will get connected to this as well, the top of it. And yeah, of course, on the right of it as well.
Okay, so I think I get that so far. So the last bit is, once you do have this connection, how do you go from this connection to getting a result?
So I will start, let's say, BFS from, since this is our undirected edges, right?
Mm-hmm.
I will pick up one node from, let's say, account of the John, and try to do a BFS from it.
Mm-hmm.
And all the nodes that I am able to reach should be merged to, let's say, John.
Mm-hmm. And then how do you know, like, what else is remaining? Like, how do you make sure you cover all the emails or all the nodes, I guess?
So yeah, we would be marking, we would basically iterating over all the nodes that are the emails that are present, right?
Mm-hmm.
And those, after marking, let's say, starting from John Smith at the email.com, we marked all the emails that are reachable by John. We look up then we look up the follow up email in the, let's say, dictionary, which one hasn't been visited or hasn't been checked yet. Try to do a BFS from that and try to find out what all the emails does it belong to second person.
Okay, and then you're gonna figure out like who they belong to, because you're gonna be already in that person's account looking through their emails. So if you look at like johnsmith@gmail.com, you're already in John's account, so you know like that belongs to John. So then you can give a result like that. Is that what you're doing?
So there can be a two map, basically, one map pointing to John to the particular email. The second one can be, let's say, only for sole purpose of creating an adjacency list to do a
Okay.
BFS or BFS.
Okay, so you're gonna have two maps. One will have the email and the owner, and one will have the adjacency list. And then you will just gonna go through like the emails and all your lists. Yeah, I think this is good. I think this makes sense. I think I'm happy with this. And so before you code, what's gonna be the time and space complexity of this?
Let's start with the space complexity first. So since I'm going to store adjacency list, right? There can be, let's say, first assumption, let's say there are n unique uh, accounts list is given, or the length of the account list is n.
Sure.
And there are at max m persons or m unique I think we would need the length of this as well. Uh, Length of the emails that we are given to us.
Yeah, so
So
let's say you have like L accounts and then like maybe like E emails or whatever, like E total emails or something like that.
let's say we have L accounts, E total emails.
Mm-hmm.
So for each person, right, there can be E unique nodes in it. So overall space complexity should be L into E. And as we are doing BFS, we would try to visit all the nodes within our adjacency list.
So when you
And
say L into E, is that like L times E or like yeah?
yeah, L into E.
Okay, let me rephrase to make this easier, I guess. So let's say you have N names, okay?
Mhm.
And you have E total emails across
Okay.
the entire accounts. So you have N
Okay.
total names and E total emails. So what would that look like?
We have N total names and E total emails, right?
Mm-hmm.
In the worst case scenario, a single mail can have uh, all the emails, right? All the emails could belong to a single person. So it
Yes,
would
but it
be.
doesn't really matter. Like, yes, like all the email, but I mean E across all accounts,
Mhm.
if that makes sense. So yes,
So
technically the first person can have like all of them, and then everyone else can have like one. Sure.
yeah. So overall space complexity would be for each person. Uh, I'm
So
trying to
yeah.
maintain is like what are the other emails a person can reach to from the current mail. So it would be E into E if I am creating the complete graph, and for each of this person, so there can be an unique.
Okay. I think that makes some sense. I don't think it's n times. Like basically, if you're saying if an email is a node in the graph, I do agree that there's like E into E edges because like worst case everything's connected.
Yeah,
And then the n times. I don't
uh,
know if
I
that's. I think it's like n plus or something
I
because
think
like you're not
and
gonna.
yeah,
Oh,
and
yeah, go
won't
ahead.
be needed as like we are keeping the separate track of like
Yeah.
each
Yeah.
email,
Exactly.
that
Yeah.
won't be needed here. So yeah.
Yeah. Okay. Okay. I think this is good. And
Mhm.
then the time.
Time complexity is we are iterating over all the unique emails. So overall emails are E, and for each of the emails, worst case we would need to travel all the other emails. Uh, okay, once give me 1 second.
Sure.
For each of the emails, we are doing a BFS, and in worst case, each of these email would be like visited only once. So I think it would be O of n, a linear complexity, because whatever nodes we are starting from, we would visit uh, only non-visited nodes. And but there is a catch here. While we are looking up the adjacency list, right? It may be like we need to iterate over all the lists.
Mm-hmm.
So it will be E of E square. At most, there can be E different edges for a particular node.
Okay. Yeah.
It does seem like it should be linear when we are doing BFS, but it would be order of E square.
Actually, going back, I don't even think you can have e squared edges because you're only connecting every node to
Mhm.
its neighbors.
Mhm.
So because you're not going to have like an n by n, you're only connecting every node to its neighbors. I don't even think you can have like e squared edges, right? Like does that like you're only connecting every node to like the one after it or whatever. Like you're not connecting it to like all of them. Or are
Mhm.
you?
Yeah, earlier I was, but I think yeah, we can. It would simplify and reduce that number of edges. So yeah, we should be connecting with the next only.
Yeah, like something like that. Because you don't need, like, for example, if you have 5 emails, you don't need to connect all of them with all of them. I
Yep.
think you could just connect, like, as long as there's some path. So I think it
Mhm.
would be like E edges and then, like, number of nodes. So I think it would be like E space or something. And then, like, yeah, like something like this. Okay, I think this is good enough. I think also for graph problems, for what it's worth, it's kind of confusing to come up with, like, time and space. But I think this is good enough.
Mm.
Okay, I think we can move on to the coding.
Okay. So first, okay, we need. I assume that an input is given in this format, and yeah, let me accept the input. So let's say,
Yeah, the input is given in this format.
Mhm. let's create a function. Let's say find emails or like DDoP emails, and it accept the accounts as it is given to us, and it is basically a list of list.
Okay.
So as we discussed earlier, we would be using basically, let's say, adjacency list to keep track of two things. One is email to name, and another thing is like what are the edges that it can belong to.
Hmm.
So, first, let's create a dictionary to maintain the mapping here. So, email to owner, and the second is we would be needing to uh, email graph. And for each of this in account email, the first is, I assume, the input as given. First is the name of the owner, and all the rest of them are email. So we can quickly separate this.
Okay.
So name and emails is equal to, and we update the same. We are going to add the current email in the edges list or adjacency list if it already doesn't exist in this email to graph. Otherwise, we would use the same adjacency list. If okay, if it already belong to some graph or we have already seen that.
Hmm.
So how we are going to do that is we also need to keep track of one thing, like what is the email, this particular email belong to which of the nodes or like which of the group that it belongs to. So we can create a single adjacency list for all of this. So I would need another mapping here that we can, let's say, call email to root.
So what
Basically,
are you using this for?
this time, so let's suppose we created a adjacency list for first account,
Hmm.
but while looking at the second one, right, John,
Hmm.
when we are scanning from left to right, we try to see like whether this email had been already used or not, and find the same adjacency list or same email group.
Ah,
To,
okay. So
yes.
you this is how you're going to be connecting. I
Mhm.
see. Well, so
Yeah,
if
one.
you, oh yeah, go
Mhm.
ahead.
Yeah, go on.
Yeah, I was gonna say like, so you're trying to see why it was used or not. I'm trying to figure out like why does that matter? Like because you're connecting emails already, and you said you're going to be traversing through emails. So you said like John Smith
Mhm.
will be connected to John at New York, and then you're going to connect John Smith to this, right? So all these three emails will be connected even if it was used or not. So why do you need this? I'm like not
Uh,
understanding fully.
Basically, let's suppose we created a graph using the first one and it contains two of these emails in the list.
Hmm.
When we are creating the graph for the second one, we need to figure out like where this John Smith is present, right?
Well, aren't you? Yeah, but can't you just like won't it just be a key in your graph? Like can't you just say like uh if it's a
Mhm.
key in your graph then like add it in, otherwise make a new key? Like like isn't that what you were doing?
No, I haven't doing that.
Okay.
So yeah, I think can I pivot to a different solution? I think
Okay.
DSU will make sense here. Like since like we have to keep the count of unique groups across all of this, right?
Mm-hmm.
So instead of like creating a graph, we can let's say assign each of this can be assigned to a single root, and when we observe a second set of emails that needs to be merged, basically merger operation, we merge the nodes across these.
Okay. I mean, yeah, you could try that.
Yeah, it would like rather simplify the implementation. Basically, we would be doing the same via the graph as well, but it would be a bit complicated here.
Okay, sure. Yeah, you could try that, and we'll see if I have any issues with it. That's fine.
Okay.
Oh, so you're gonna go towards DSU? Okay.
Yeah, yeah.
And in your DSU, are your like nodes
Mhm.
gonna be emails still?
It can be mapped to an index, or we can compress this. Basically, use a map to see if we have seen this or not, and map it to a number, hash it out to a number.
Yeah, no, I mean that part makes sense, but are you gonna be combining emails or accounts? Just want to make sure which one you're doing.
Combining emails only.
Okay, got it.
Yeah.
And why are you making the parent -1? I guess like isn't it if you have two nodes and both their parents are -1, like technically they're not connected, but this will give you false.
Mm, uh, it will return parent only, right? If the parent of v is equal to -1, then we
Oh,
will.
I see. I see. You're okay. So you're putting in -1, but you're returning the actual value. Okay, that makes
Mhm.
sense. Okay, sure.
Yeah.
Okay.
Uh, yeah. So similar thing we would be doing, but we would be using the DSU to keep track of who's the current parent of the emails.
Okay.
And yeah, we would need the size here. Uh, like overall, can I assume, let's say, a max limit on the size and create the DSU?
Uh, sure. So you mean like this the number of emails you have?
Yeah. Or
I mean
let's.
you can also just count it, right? Like you can
Uh-huh.
go through and count
Yeah,
it.
let me quickly count like number of unique emails in this.
Sure.
Basically, we would be assigning it to a key as well, so that can be used here. So
Hmm.
email to ID.
Yeah, because I don't think it's a good idea to just hard code some like 10 times 10 to the fifth, and then there's like 10 emails.
Yeah. So
Okay.
it quickly hashes out email to each of our integer, and if it is not present, then we only update the dictionary. And I'm creating the DSU using the same.
Yeah, that makes sense.
Mhm. And now we are iterating over the emails. First of all, let's say uh, unite how union process would work, right? Let me walk you through this. We
Sure.
got a list of the emails, right? We pick up the first email and follow up the email. So instead of uniting each other, we can just keep uniting on the zeroth index of the list. So if we had like three items, we would have united John with the second one, John with the third one.
Yeah.
John,
Yeah, I get it. So basically, for every email on the list, you're just uniting all of them with the first one, because as long as you
yeah,
unite in some way, it doesn't matter how. Yeah, that makes
yeah.
sense.
Mhm.
Got it. Okay.
So name, email, and yeah, first email is account email, emails account, the first entry in this, and we are iterating over all the emails and keep uniting with the first email. So
Mhm.
DSU dot unite. Also, we need to since like we are using indices over int, so we need to hash this using our email to ID.
Yeah.
So I'm quickly doing that as well. So this is email to account, email to ID.
Mm-hmm.
And yeah, after this, we would have like union of all the emails for, let's say, first group. When we
Mm-hmm.
move on to the second group, we found out like John Smith is already present there, and we united all of this with the same some other email.
Yep, makes sense.
Mhm. In this case, like one information that we have, I think, lost is the lookup part, like how to get like uh, uh, this email belong to whom, or what is the user of the email that we discussed earlier. So we need to maintain that hash as well. So let me create that as well, and we can update here. So email to owner, and for each of this, we keep updating the email to owner list. And once we have updated it, the second part is like constructing this list or the result where we are finding the who is the owner, and the rest of the nodes represent like what are the different emails that belong to it. So for this, what I'm thinking, we iterate over all of this unique emails in our email to owner, that or we could iterate over email to ID and see like try to find out like whom this list belongs to or what is the root of it. Basically, each of this belong to a each of this entry will belong to a single root,
Mm-hmm.
and we can keep appending the or updating the root list for this.
Okay, yeah, makes sense.
So uh, first I'm keeping the root ID. Later the ID can be used to get the this thing, right? Uh, email to ID. We can find out do a reverse lookup and find the ID, basically ID to email as well.
Mm-hmm.
Okay.
Can you do a ID
Mhm.
to email? You don't have it right now, right? So I don't
Yeah,
think you
yeah,
can.
yeah. I was just going to create a simple hash map for the same.
Sure.
If we have already seen this, like it already exists, the root of this, we just append or like update to contain the update the ID to contain the list of the emails IDs.
Okay,
So
so basically this root ID thing is gonna have a root email and then a list of emails that are like it's the parent of, right? That's what it is.
I would, yeah, I can go with the list as well as set. So I'm currently thinking of set so that when I add this John Smith again, right, while iterating over this,
Mm-hmm.
it doesn't do like double count or comes twice.
Sure, makes sense.
Yeah. So if root is already exist in this, so I will just add this.
Mm-hmm.
Otherwise, I will if it doesn't exist, there is no entry of this email or there is no root ID as of now, I will need to create another root. So
Mm-hmm.
and I need to add the email in this as well. So I'm adding that. Once this is done, so this would basically give us IDs to ID map, basically root email, let's say johnsmith@gmail.com and rest of the emails. Now we
Mm-hmm.
need to construct the second part as we discussed, right? We need to replace, instead of using the IDs, we need to replace it with the names and the list of mails.
Yeah, right now you basically have like this root ID thing has like a parent ID and then list of IDs, but you actually need the actual emails and the name to return
Yeah.
an output. Yeah, makes sense.
So let's call it results. Results contain the list that would be we finally would be returning or printing as per the required format that is given to us.
Mm-hmm.
What we can do is like we can iterate over all of the root IDs to emails. So email IDs. And we can append basically and update the result here. So first item that we are adding the current result is the owner or the name of the user, that is John. So that can be found out by the reverse lookup in email to owner hash map that we have maintained.
Mm-hmm.
So that is going to be, first we need the email, root email. Root email is going to be this thing, right? ID to email reverse lookup.
Mm-hmm.
And we append the same. And then for rest of the email IDs, we just iterate over the in email IDs and update in the same current result. So email and email IDs. We just append the reverse lookup for the ID to email of particular email ID.
Mm-hmm.
And finally, basically it would return the result.
Okay. Do you want to try to run it on the test case? I don't think we have time to do a dry run because we're already
Yeah.
low. So just try to run
Okay.
it on test case and bug fix if there's any problems. And you can use the one that I provided.
Mhm. Okay. You are asking to directly run the code, right?
Yes. You wanted to run
Okay.
the code, right? So
Yeah.
make sure it's like doing the right thing and you can bug fix if there's any problem.
Yeah. Find the earphones. Okay, key error zone where we are looking at it. Solution 560, line number 60. Okay. Email to ID, email to ID. First email, email. The John shouldn't be occurring in the email list. I think we have constructed the emails somehow wrong.
Yes, I agree.
So we are iterating our emails and it is starting from account email ones to following. Okay, first email is account email 0. One more word. Okay, this should be first item from this, right? Emails instead of like account email. Account email 0 points to the name, and
Okay,
this should be kept first from the email list.
that's
So
right. Yes.
yeah, I guess this should fix this.
Okay, let's give it a go.
Yeah. So when I did a zone.
There's like some weird things. I think if you run it one more time, it'll go away. It'll be normal now.
Okay, John Smith. Yeah, it is printing out the list.
Mm-hmm.
John Smith.
But it
On
didn't
dot.
connect correctly, and you don't
Yeah,
have the name.
yeah. We don't have right name here. So
Mhm.
current address is empty and root email. We did append it the root email. Okay, owner. We didn't append it the owner here. We need to append the instead of root email. We need to append the. We need to have an owner here that can be found out using this email to owner.
Mm-hmm.
And instead of appending the root email, we need to append the owner here. Yep.
Okay.
So John and the rest of the three emails, Mary single email, John the last email.
Okay, I think this is correct. So let me ask you some stuff because I wrote down some stuff and maybe it's wrong, maybe it's not.
Mhm.
Okay, so line 49, you
Mhm.
have email to ID email equals length of email to ID, right?
Yep.
So basically, let's say this thing has like nothing.
Mhm.
So what that would do is it would say like, let's say your email is like whatever A, this would be like 0, right?
Yeah.
And then you do ID to email, email to ID email equals email. So if you do
Yeah.
it that way, actually, I think that does work. For some reason, I thought you had an off by 1, but I think this does work. So actually, never.
So yeah, it wouldn't have worked like if I had used length here as well. So this would
That's
have
right. Yeah.
yeah.
Okay,
That's why I used this one.
that's right.
Yeah.
And then yeah. So the other question I had is maybe I was off here as well. On line
Mhm.
72 and line 73, you basically say if the root is in here, then you add to the root. But if the root is not in here, like I would have thought that ID needs to be root, not ID.
The ID needs to be
Like this needs to be root here.
oh yeah. This needs to be root. Yeah.
Yeah. Okay.
Mhm.
And then one final question. So right now, your DSU,
Mhm.
the way you have it written,
Mhm.
is not OV1 like. So
Yeah.
normally DSU is so what would you need to add to make it faster?
So yeah, I can basically we need to add like sizes here, and merging should be happen based on the size. The
Uh-huh.
larger half, basically we should be connecting larger half to the smaller half so that we always move to the while we are trying to find the parent,
Mm-hmm.
we are able to find it in an amortized time.
Yes.
So
Okay. But we can move on because we're running a little bit low on time. So let's just move on to the next question. Yeah, I'm pretty confident you can code that, so we can move on.
yeah.
Okay. So next question. Let's see. Let's do one that doesn't take a ton of coding. Okay. So, okay. So you have a chocolate that has a bunch of chunks. Okay.
Okay.
So a bunch of pieces. We can call this like pieces. And let's take an example like this. And I have a K, which means how many chunks I want to divide it into.
Okay.
So K is like chunks. And basically what I am going to do is I'm going to cut it in some way where I cut in some chunks. So maybe an example might be like, maybe this will be one chunk. Maybe this will be another one. Like this.
Okay.
And I'm going to give all but one piece to other people. And because I'm not greedy, I'm going to keep the smallest piece. And what I mean by the smallest is basically like the sum of the array. Sum of the array. So in this case, I would keep the 1, 2. Okay?
Okay.
And so basically, yeah, go ahead.
Yeah, go on and give the 3, 4 these chunk of pieces to the 4 people.
Yes. So I want to maximize my chunk. So basically what I want to return the maximum chunk I can have if I do this kind of thing. So in this case, it would actually be this. You would cut this way. So it'd be like 6, 7, 8. Let's say, well, it's actually in this case, let's say there's K is 6. So if this case K is 6, I would cut it like this. And then that way, the most I can ever have is 6. And there's no better way to cut it than this. So basically, that's kind of the problem, is you're given like an array of pieces, you're given K chunks, and you give everything else away, and you maximize your own. And like, what's the most I can... So you keep the smallest, and like, what's the maximal total you can have if you do it this way. Yeah, and feel free to ask anything if you want.
So yeah, we need to basically divide the subarray in, let's say, K chunks, right? If I try to read it other way around, we need to divide this given array into K chunks, so that the divisions or the arrays should be continuous.
Yes.
And we want to minimize the overall sum for a particular subarray.
We want to maximize the smallest chunk we have. Yes.
Maximize the smallest chunk.
Yes. So you split it into some chunks and you want to maximize the smallest one. And that's the answer.
So this generally like goes into the, like, I think binary search sort of things, where let's say since we need to maximize our chunk size, right? Maximum sum. We try to, let's say, fix a maximum sum that we can achieve from a given array, and try to see whether we can, using that sum only, we are able to split it across K different chunks or not.
Okay.
And if we are able to split it, since we need to maximize our chunk, right? We try to find out a greater sum, whether that can be also used to divide the given array in K chunks or not. If we are not able to divide the array into K sub-arrays, we reduce the overall our expected or guessed, let's say, guessed chunk size, guessed sum at any point of time.
Okay, so you're basically going to binary search for like what's the best we can do and try to split it in a way to see if you can get it. Is that correct?
Yeah.
Okay. So can you walk through, like, I guess, like, let's say you pick some random number, like the best I can get is like 8. How would you do the splitting?
So we would need to define the, let's say, boundaries for this first. So the minimum sum that I can get would be the lowest number among these, right? For any subarray. So I can fix that as the lowest sum. Let's say among all of these numbers, 1 is minimum. So my lower bound is 1. Among this, what is the maximum overall sum, maximum sum that is possible of this subarray? Obviously, we are going to divide it in K equal chunks, right? So that we can utilize in our bounds as well. But overall of sum, divided by k, that can be, I think, our higher bound.
Yeah,
If
I
it
think that makes sense. I think that's a very good
Hmm.
approach. Yeah.
if it is also, it would depend whether it is able to completely divide it or not.
Hmm.
So
So what if it
let's say
can't?
if we can, I would try to pick up, let's say, next multiple or divisible item from it. So if let's say overall sum is m
Hmm.
and we aren't able to divide by, let's say, k, so the best would be way to be to get the next multiple of k here to keep it as the upper bound.
Okay.
So yeah, I would just pick this number and also multiply it by k to get the next possible sum. Obviously, it won't be possible, but we can use it to do a binary search on it.
Yeah, and realistically, so just asking you about this. So like, if you do like m or m plus k or like m plus 2k or something, is that really
Mhm.
going to affect our solution very much?
No, since like we are using binary search, so overall, uh, linear addition won't affect that much. We can just like we would be able to achieve in log n. Uh,
Right. So we can have some kind
instead.
of simple top end as long as it's reasonable. It doesn't need to be like the perfect number. Yeah, it makes
Yeah,
sense.
so I think we can use the sum as overall. Like overall sum division is not going to hardly affect the time complexity of the solution.
That's right. Yeah. Okay. Yeah, I think this works. I think this makes sense. So yeah, so
Mhm.
can you walk through, like, let's say I picked 8 in this
Mhm.
case, like my total is 8. How would you do the splitting?
So I would do the splitting optimistically. I would try to scan from left to right, and if I can accommodate the, let's say, current value in the sum, I would increment it, or I would start counting another chunk with the given number. So let's start with one sum as expected, sum as 8.
Hmm.
Scanning from left to right, we see 1. We can current sum is 0. We can accommodate it. We saw 213 that we can also accommodate because it is less than it. We saw 3 plus 3 is 6, which is still less than it. We can accommodate it.
Hmm.
We move on to the next one. We see 4, 6 plus 4, not that exceeds 8. So we break out from the previous chunk and start a new chunk from the 4. So my current sum become 4, chunk count become, let's say, 1, and we keep on continuing the same. We saw 5, 4, 5, 9 that exceeds 8. So we break out and increment the, let's say, chunk count to 2, and yeah, start another chunk with the sum of 5.
Yeah, so can
And
you write down what the chunks would look like after the split, basically?
uh,
Just so
yeah,
I can understand that you're, yeah. So
so
just write down what, yeah.
for the first iteration with the given value 8,
Hmm.
the expected chunks would be 1, 2, 3, and so 4, 5 won't be there because we have kept the sum as 8.
Hmm.
5, 6, 5, 6 will also break out since it exceeds 6. 7 won't be there, and similarly, yeah, 8 and 9 we cannot even accommodate it. So yeah, the given condition when we are not able to accommodate it, right? It point us we should increase the chunk size. So
So what's the thing we're testing for? Like this sound, like when you're
okay,
binary search, you're basically binary searching on like what's the chunk I can get, right, for myself. Like that's your
uh,
condition, or am I wrong there?
binary search is for a given, let's say, fixed sum, right?
Uh-huh.
We try to, let's say, fixed on a particular point. We are trying to find whether we can also improve on this or not. If this is able to satisfy our solution, satisfy our condition or not. The condition is given a sum. Can we divide it in, let's say, k chunks or not?
Yes. So this sum represents basically like the answer, right, that you're going to be returning. Um,
Uh,
so so in this case, for example, why
mhm.
do you have it like if I have it like this, right?
Yep.
The chunk I'm going to give myself is this.
Mhm.
So like it doesn't make any sense basically. Like let's go back to the easier example, the one that we should get the right answer. So let's say the sum is 6. So
Mhm.
basically when the sum is 6, we should split it in this way up here, right? Um, because that way we know, like, yeah, we were able to split it into 6 pieces, and then every piece has a sum of, like, you're taking the smallest. So if I was to split it like this, it would be incorrect, because then I would take like a 4. So how would we need to split it for 8? Yeah, correctly.
Yeah, so we need to split it such that the smallest sum at least exceed 8.
So how would we revise what we were doing?
So yeah, we keep on adding the items till we, let's say, we are able to reach the sum that is greater than equal to 8 or not. So for the given sum 8, right, what would be 1, 2, 3? This account for 6. We need to also consider 4 into this, so that the sum of the chunk is greater than equal to 8. After that, 5, 6, we would be piecing together 5, 6. The next item 5, 6 exceeds 8. Now we would move on and add 7, 8 to a new chunk. And later 9 can be added. So these is the minimum continuous subarray whose sum exceeds or equals to the expected or guessed sum size.
Okay, yeah, it makes sense. And then, so basically I want to answer these 3 questions. Let's say number of chunks I get is less than 8, equal to 8. Or not 8, k, sorry, k. So less than k, equal to k, or greater than k. What should happen in each of these cases in your, like, search?
So if number of the chunks is less than k, the problem is, like, we have picked up the sum too large. Like, we divided the, let's say, the given subarray at very long points. So we need to shrink that. So one way could be to decrease. The obvious way would be to adjust the boundaries. So we would be basically lowering the right or higher bound of the binary search space. And if already it is equal to k, then we need to optimize for, like, lowest sum that we are getting. We need to maximize that, right? So we should increment or update our lower bound of the binary search to, let's say, the given midpoint that we are checking at.
Yep.
And if it is greater than k, then obviously we are getting more chunks. So we need lesser chunks. So one way could be to increase the sum or the expected sum in the next step. So to do that, we should obviously increment the lower bound of the binary search to the mid or expected value that we are looking at.
Okay, yeah, makes sense. So let's code it. We don't have too much time left, so yeah, let's do that.
Yeah. Okay. So yeah. I am giving left 0 to, like, just to simplify and not complicate things. Let's
That's
suppose,
fine.
Yeah.
So here, I'll paste the function signature for you to save some time. So we can get rid of that, get rid of that. There you go.
If chunk count are greater is less than equal to k, then obviously we can less than equal to k. Let me quickly cross verify the.
That's fine.
Yes, this condition. I will verify just that after completing this function.
Sure.
If current sum ever exceeds the target sum,
Mm-hmm.
actually we should look up while we are adding or trying to add. If previous have already given us value greater than the target sum, then we can start adding this to a newer chunk. So current sum become high and we start a newer one. Otherwise, we add to this one. Even if it is equal to, and obviously when we are starting, the count should be 1. And for given when we are trying to guess for a given sum, what is the expected the chunk that we have guessed? If it is less than k, then I think less than k, then we don't go high. So and come out. Some code करना होगा तो okay. Right should be decreased here, and here left should be increased.
Okay.
And if this overall chunks that we are counting with the given sum is less than k, then it means basically ki we the sum that we had picked up, right, was quite large. We need to decrease that.
Mm-hmm.
On account of that, I adjusted this condition, and whenever if it is greater than equal to k, right?
Mm-hmm.
Less than equal to k, if it is less than, so we need a merging condition. If it is equal to k, then only we are going to return the answer. So
Mm-hmm.
for that, I'm just thinking like in which way we should keep the equality and update the condition or
Right.
update the answer. So we should always update the answer when it is greater than, and move this condition to the if it is less than, we are not updating the answer. Otherwise, we can update the answer to the since this here the number of chunks would be greater than equal to k and would be able to satisfy the condition.
Mm-hmm.
Should I do a quickly dry run for this?
I would just try to run the code and debug, and
Yeah.
I might give you like another example. We don't have time to do a dry run, so just run the code and debug.
Okay. K was
6. Oh, you probably have to comment out the other stuff, I guess.
okay.
Yeah. Let me do that real quick for you. Okay.
Okay, it is just printing 6. Okay, the answer or the maximum overall sum value, minimum sum value. So for this, I expect 6 was the given answer, right?
Mm-hmm. Can you come up with any more test cases while we have a little bit of time? Come up with any more test cases you'd like to test just to make sure it's working.
Yeah. So obvious edge cases I would like to test is, let's say we need to divide it in, let's say, basic 3 numbers or 3 continuous. So 1. Now let's increment one of the bounds. What can break it? So five. So we need to divide this given array into 3 chunks, and it is stating minimum sum should be 2.
Mm-hmm.
Uh, there is no. I think this is breaking this test case.
Okay. So what should it be? How would you split here?
One way is to 15114. That gives us 2, and there
Mhm.
is 151415155, but that gives on 1. So
Yes, I think
shouldn't
this is actually right.
shouldn't it give like 1 as the okay?
Shouldn't you give 1, you said?
Yeah. So we are able to get 1, right? 151 and 14.
Yeah, but you want to maximize the smallest chunk, so the other
Oh,
way would be
okay. Yeah,
better.
yeah.
Yeah.
Then yeah, it is 112. 2 would be
Okay.
yeah.
Let me ask you a couple questions about this one, because once again, I thought there were some bugs, but maybe not. So happy to hear your opinion. So for 1, you say the count is 1, but in reality, you might have 0 chunks with this sum, right?
Yeah.
So I think that's a bug.
Mm-hmm.
So how can you fix this get chunk function?
Yeah. So
Like, I think it works for these test cases, but I'm not confident it will work overall. Because yeah, what if the sum's like 1,000,000?
so,
You don't have any chunks, right?
yeah. So one way could be to, instead of having count updating the count of the chunks when we are like starting a new chunk,
Mm-hmm.
we can keep track of count as 0, and
Mm-hmm.
we can accommodate, let's say, try to think in a way like unfinished chunks. So whatever way we are accommodating or accumulating are in current sum. So even if current sum is not 0, right, in the end, so that contributes to a some chunk. So I can add basically 1. Overall count would be the same, and 1 for like unfinished chunk
Okay.
with the given condition. So if current sum exists, then we add 1, otherwise 0.
Okay. And then other question. So
Mhm.
this binary search is actually not a binary search. So can you look at your while loop and see what you need to fix?
Oh. So yeah, it was not. We were not updating the bounds correctly. So left, right. I think it is correct now.
So I think it should be like that, but yeah.
Yeah.
Okay, so let's stop here. So how do you think you did? What do you think you can improve on? Things like that.
A couple of things. A bit, I think, fumbled on. I fumbled on some of the things in the starting, and like first of all is the communication. I
Mm-hmm.
can do a better on the communication, and yeah. But yeah, let's get to. I would like to hear it from you.
Okay, yeah. So I actually thought your communication was okay. I think for the first, so granted, this is like because you're applying for senior, and I would say these are on the easier level of hard questions. I don't know if you'd agree or not. Basically, the first one so I had 2 questions planned. And the second one, because we went over on the first one, like I think it took like 40 minutes. I had to make a shorter question for the second one because I was like, there's just no way you're going to finish the second, like this one that I had planned. So I definitely think speed is one thing. Where ideally you would finish each question in 30 minutes. I think totally doable, especially the second one, obviously. But yeah, so yeah, and I think there's like a couple of reasons that you took a while. So for one thing, you basically had I'm gonna do a BFS, and so for this first question, BFS, DFS, and Union Find are all fine. Like they're all doable. But this one is like there's a lot of parts you have to do. So you notice you have to like do something and then make a parent and then also like combine them into some. So no matter which way you pick, there's still like a bunch of things you have to do. So it's like a long coding one. And I think the main problem you had was I think your time and space was a little bit off. Like I think you said it was like squared, which it's not, because yeah, you're basically joining everything to the one after, which can't be squared. And the other thing is you did like a hard pivot, which is like not ideal. Like you really want to avoid this as much as you can. So you want to come up with a plan that you're pretty confident in and stick to it, instead of like, I'm going to do BFS and then like, this is how it's going to work. And then 20 lines in, you're like, oh, just kidding, DSU.
Okay. Yeah.
So that you can pass with it, but it's very, very hard in my opinion. So ideally you should come up with like, hey, actually DSU is like the easier thing for me. And for what it's worth, like people can't you can do it either way. I don't think one's harder than the other, but whatever you come up with, ideally you want to stick to it, unless it's like, this is just not going to work. So I think that was the main like red flag, was like you did something and then you completely pivoted out. And I was like, okay, yeah, this makes sense. You're doing DSU. Okay. But I think as far as like your coding and stuff, it was not too bad. Like I think your variable names were good. There was a lot to code here, and you kind of like every time you ran into a problem, you kind of like figured out how to do it very, very quickly. But the main time sink was the big pivot, right? So if you come up with something, you plan it out, that takes some time, you start coding it, that takes some time, and then you completely pivot. Now you have to like do something completely different. So and if I was like, and the interviewer might be like, oh, you're pivoting, explain to me what you're pivoting to, and then you just run out of time. So that's like the biggest thing. And then let's see if there's anything else. Yeah, so I think even though like your code technically worked, I think I pointed out some bugs to you that that you didn't notice. And it's kind of hard because we had so little time. It was kind of hard for you to write like more test cases and see if this like if you had some edge cases that failed. So like the main one I gave you fine, but you still had some bugs. So ideally you bug fix yourself, and you like, honestly, this is like a pretty annoying question, but ideally you can like bug fix as much as you can, and then you don't have like bugs in your code. And then the other thing, for the DSU, so it's in basic data structure shit, basically like you can't, if you don't use ranks, it's going to get really slow. So I think you can get to like n squared or something. And then basically your time complexity drops off and your solution's not good. And for what it's worth, adding ranks is like 3 more lines of code. So if you are going to use DSU, I would add ranks, just like always. And then have the correct solution there. Does that make sense?
Yeah. Got it.
Okay. And then, yeah, I think your results are fine. I think your debugging was fine. Like, yeah, I guess if you run your code, ideally you have more time. And then I could see like, okay, like realistically, probably when you run this thing, it's not going to work. Like you'll have at least some syntax thing or something, because there's a lot of code here. And I think you were able to like debug pretty well. Like things didn't work, and you were like, oh, this is this and this is this. So that was pretty good. So the main thing, honestly, was like just stick to, like, ideally come up with something that you're confident in and do that. And then for these types of problems, like I personally would just code DSU, because I was like, yeah, DSU makes total sense. And then actually DSU you can do a bunch of different ways. You can either join accounts or you can join emails. Either one works, whatever you prefer. And basically every problem where you have to join stuff, I just use DSU, even though like technically I think you can use like DFS or something. In my head, it's like less intuitive and more complicated. And you kind of realize that as you were coding. So yeah. And if you know it, you might as well use it like so. So that's why I just encourage people to learn DSU, because for a lot of problems, it's way easier in my opinion. Like anything where you have to join stuff. Okay. And yeah, so for that one, I basically gave you a 3 from problem solving. I actually thought your communication was fine. Like anything you were doing, I kind of understood. I gave you a 2 for speed because I think you finished in 40 minutes instead of 30. And then a 3 for DSA because you had some union find errors and some other stuff. And then a 3 for coding because you had some bugs that, like, even though the code worked, it still had some bugs. So ideally, you can like minimize those yourself. So this would be like a lean hire or something for a senior for like a harder interview, in my opinion.
Okay. Yeah.
And then for the second one, so you restated the problem. I mean, this one, I do think this one was like, even though it's technically hard, I don't think it was that bad, and I just had to find something that didn't take forever. That wasn't super easy. So the nice thing about this one is you came up with binary search basically instantly. Like, I don't know if you've done this problem, but a lot of people struggle with figuring out like what to do here, and then they just spend a lot of time like what even algorithm do I use? So you came up with like what needs to happen instantly. So that's good. And I think for this type of problem, even though it's hard, I do think it's reasonably intuitive to be like, yeah, I need to like maximize my trunk. I can just binary search, and then that makes a lot of sense. And so I do think your like ability to go from problem to solution is pretty good. For the first and second problem, like you were able to come up with like an idea of what to do pretty quickly. So I think that's good. And then oh yeah, so the thing that I wrote is when I was like, okay, explain how you would like make the chunks. I think you had like, I think you were a little bit confused and like we're doing it incorrectly, because basically like if you want, like, you need to understand that like you need to maximize the minimum, so then the only valid chunks are chunks that are bigger than whatever value you pick. And so I think the chunks you were writing were like incorrect, and I had to give you a little bit of a hint there. And then I don't think I asked time complexity, but honestly for binary search it's pretty easy, so I'm like 95% sure you would have got that, so I don't really care about that. And then in your get chunk count with sum, for what it's worth, I still think it's incorrect. Because for example, let's say your sum is like 1,000 and your chunk is like 1, 2, 3 or whatever. Let's say this chunk adds up to 1,000. This chunk adds up to 1,000, and then the last one adds up to like 5. So your current sum would be like 5, and that would be incorrect. So I think the correct solution would have been to actually how you had it originally. So it would be just like cursum plus I if cursum is greater than or equal to s, or what, target sum, then count plus and reset. I think this actually would be correct, and then this would be 0. So yeah, and then you basically just return the count here. Yeah. So I think, does that make sense how this would be correct?
Yeah, that would be simpler as well.
Yeah, so I was hoping it would fail the starter case with like your incorrect solution, but it passed. And but that's like, yeah, basically if we had more time you could have written like more test cases and tested for more things and so on. So it's kind of like, I think in both of these you had some bugs, and then the code happened to work, and I was like, I'm pretty sure this is still incorrect, and I'm pretty sure it will fail given enough test cases. But so that's why I wanted to double check with you. I think for the first one, some of the things that I thought were wrong were actually right, like this email to owner thing. But then this one was definitely wrong, and then some other stuff. So that's why I wanted to verify with you. Like, if you can explain to me why it's right and I'm wrong, happy to be wrong. But I'm pretty confident that this is like incorrect. So I would say definitely for like a problem like this, it's a little bit easier to code, and I would expect you to have less bugs in your code because this is like 15 lines of code. So you had a couple of things that are wrong, like binary search, and then you had that one, and then I think you had like one other one. But I do like so for what it's worth, for binary search, I do like. Do you use this thing for like all your problems, like this mid and answer and this, and then you just return the answer? Do you try to like stick with this?
Yeah, I always just stick with this template.
Yeah. So I think that's really good, and I basically do the same thing. I think I have the identical thing to you. And the nice thing about sticking to something that works for everything is you ideally code it bug free, but you still had some bugs. So, but it was like I think in the binary search you only had the like left plus 1, which is like, I mean, I'm pretty sure you understand like that it's not supposed to be that. So I just basically said that was like a syntax error. I don't really care about that. instead of an understanding error. And then in this one, though, you did have an understanding error where you coded incorrectly and then you revised it to another incorrect one.
Yeah.
So that definitely could have been better. So I would say this would also be like a lean hire type of thing for a hard interview. Like I didn't have to give you very many hints. I think for this one, I only had to give you the hint of your chunks are incorrect. Everything else was fine. And then you had some like code bugs. So I think for this one, I gave you a 3 for problem solving. I think communication was fine too. Like I understood what you're doing. 3 for speed, 4 for DSA, and 2 for coding because you had a decent amount of bugs and not a lot of code. So like the more complicated the code gets, the more I'm fine, like, letting it go. But if it's like 10 lines of code and like 3 lines are wrong, then that's not great. So I would say this is like, basically like a lean hire for like senior for like a tougher interview, in my opinion. But there's definitely things you can do to improve. And also in this market, like I wouldn't try to set the bar at like lean hire. I would try to set the bar like at a higher thing, because for a lot of jobs, like there's like one spot available and then people are going to do better than that, like generally. So you ideally want to do like very well, not just like barely pass to the point of like, yeah. And so I think the main things is, like code with less mistakes. Don't pivot from a solution that you go with. Maybe like think it out a little bit better before you start coding, especially for the second one or for this first one. There's like a lot of code. So if you pivot, it really hurts you because it takes a long time. So definitely like try to think of a solution, try to plan it out a little bit more before coding and make sure you're confident with it. And then obviously speed. Most people have to work on speed. But yeah, everything else is pretty good. I think you're like going from problem to what needs to happen is good. It's just you're a little bit off in implementation detail sometimes, or you know what needs to happen. When you code, you have like too many bugs. So I definitely think like work on the coding aspect of it and make sure you can code bug free. Ideally, like I think the thing that I do really well is I can code like really big solutions that are basically bug free, like right off the bat. Maybe I'll miss like a semicolon or something, but for the most part, the logic is good. So like the red flag for coding is like you have logic errors, not just like syntax errors. So I would try to make sure to like try to find some things that are like kind of long, try to code them and make sure it's like working. And if you have like some syntax errors or something, it's fine. But if you have a lot of like logic errors, then that's not great. So I think that's the main thing. Does that make sense?
Yeah, completely agree.
Okay. And then, do you have anything else or, yeah?
No, it was like the experience.
Okay. And so curious. So for this difficult one, not a lot of people pick it. So I'm curious, like, were these questions too easy, too hard, just right? Like, what's your opinion?
First one, I would say like was intuitive, quite intuitive, but I started with the DFS and basically wanted to do it in a linear time or sort of thing. So yeah, I would say it was medium, not very hard. Second one was like I have like a good grasp of binary search problems. Like I get the intuition quickly, like because I've done a lot of them. So I was able to figure it out quickly. Yeah.
Okay, so so like the original one I had was more complicated than the second one, but because we were so low on time, I was like, I'm gonna have to pivot. So maybe I'll just like I'll see what I do there. Maybe I'll like it's kind of hard when there's like 20 minutes left and I have to ask you another hard question. Like, what do I do there? But yeah, it makes sense. So I can make this a little bit tougher in the future. That's good feedback. Okay, cool. All right. So I think and if you want to book another one, feel free to. I basically ask like don't book 2 in the same month because I'm like booked for a month out. So you can definitely book another one in the month or something if you want some more.
Yeah, let me practice sometimes and I will probably get back to it.
Okay, yeah, sounds good. All right, see ya.
Thank you.